The next thing that you need to do is take on the art of reading a circuit diagram. If you've not encountered circuit diagrams before, they do look very, very baffling things, but they're not that complicated once you begin to understand what the various symbols mean. Very broadly, this bold black line running along the bottom, sorry this doesn't line up, which is very irritating. This bold black line running along the bottom of the diagram here represents the metalwork of the chassis, and that's used as a return point for lots of circuits in the set. A radio is not just one circuit, there's a whole series of circuits that all connect together. The left hand side of the diagram is where the signal comes in. There's the aerial, the signal for the aerial. That's the aerial socket in the back of the set. That's the earth socket in the back of the set, and that represents an external earth wire down to earth. As I said at an earlier point in these videos, earth in this context doesn't mean, it's not the same as the earth in your house mains. It's a point relative to the rest of the set, but we won't get bogged down with that at the moment. Now, at the other end of the diagram is the output of it all. Here's the loudspeaker, and in between we've got a series of circuits which we'll look into in more detail later. This bottom section here, that's sort of set off to one side, or rather underneath, is the power supply. It's nothing to do with the passage of the radio signal through the set. This is here just to provide the power supplies for the radio circuits to work. Fault finding is an exercise in applied logic, and if you think about it, if this end of the set that's producing the output for the loudspeaker isn't working, it really doesn't matter what this end of the set's doing, because the set as a whole will simply fail to work because this bit doesn't work. So we always start with logical fault finding procedure at this end and work back through each circuit, verifying that each one is working. Once we've got any faults cleared at this end of the set, there's a very good chance the whole set will begin to work, because these circuits may well be working fine. There's no point in looking at any of this area of the set until we're satisfied that this part is operating correctly. And we can do that without a lot of work. Our electrical tests will start though with this mains input. Here's the AC mains coming in, double pole switch. This particular set has a thing called an auto transformer, which is not uncommon, but is not the most conventional form of power supply. But I don't want to get bogged down with that at the moment. We will check that there's continuity and everything appears to be joined as it should be at this point, and then we'll explore what happens beyond this point, which is the rectifier valve, which supplies the direct current required to run the various stages. Those are symbols for the scale lamps that illuminate the tuning scale, and this line here terminating in just X, an arrow and X, means that that's the source of power for the heaters in the valves. If you look at each valve, X, that's that connection there, and that's the power supply to heat the valve. That's what we see lit up when valves are on, and that represents a connection down to chassis, which is actually the same point as that black line. So without further ado, we shall get the meters out, start doing some checks.